Hello friends, welcome to a new section, and in this section we'll learn how to generate response spectrum curve in SAP 2000. Before that, let me give you an introduction of response spectrum. Suppose that you got a building, okay, so it can be any mass. So let us take an example of a building, right? So when this building is subjected to constant ground shaking, that is earthquake or vibration, so it gives response. Okay, so response can be in the form of acceleration or velocity or displacement, right? Okay, so using any method, if you measure, for example, let us take acceleration over here. So if you measure the acceleration and plot the acceleration in y curve, so acceleration to plot here with time period in the x-axis. Okay, so in the y-axis you plot acceleration, and in the x-axis you plot the time period. You will get a certain curve, right? So this plot over here is called as the response spectrum. Okay, it is nothing but the plot of the maximum acceleration versus the time, right? Again, let us see another example. So here we'll see three buildings. Okay, so this is our building 1, and this is our building 2, so it's just a single story, and this is our building 3, and it's tallest of all. Okay, right? So this building has got mass m and stiffness k. So let's give it m1 and k1, right? And let us suppose that this building over here has got mass m2 and stiffness k2, and this building over here has got mass m3 and stiffness as k3, right? So we can get the mass to stiffness ratio by doing m by k, right? Okay, so we know that the formula for the time period is t is equal to 2 pi root over m by k. Okay, so if this ratio is same for all these three buildings, that is, here you can see that it has got mass m1 and stiffness as k1. This building over here has got lower mass as compared to this building because it is higher. But if this building has got higher stiffness as compared to this building, then this ratio can be same for these two buildings. Okay, so let us assume that time period for this building is t1, time period for this building is t2, and time period for this building is t3. So if this ratio is same for all these three buildings, in that situation t1 is equal to t2 is equal to t3. Okay, let us assume that structural damping for these three buildings is same. That is, structural damping for this building is xi. Okay, this building is also xi, and this building over here is also xi, right? Such set of structures with same natural period of oscillation and same structural damping exhibit same time history response subjected to the same earthquake ground shaking. Okay, so what it means is that, so in this situation, if we plot acceleration versus time curve, so acceleration versus time curve here, and for this building also if we plot acceleration versus time curve, and for this building also if we plot acceleration versus time curve, all three curves will be same. All right, so this is the theory of response spectrum.